Hello everyone, welcome to the channel. We are going to learn one of the most important topics, structural biology. We're going to learn how to superpose its MOE. We're going to calculate the RMSD, Root Mean Square Deviation. We're also going to compare wild type protein and its counterparts. We'll see structural alignment and how to do so in software, how to bind pocket, how to compare binding pocket, and how to observe the ligand position, how they change even after we have aligned. This is what we are going to do in the video. So if you have been following us, or if yes, you have been following us, you know and check our files. And if you are not following us, if this is your first time on the channel, I would like you like the video, subscribe, and also share. So now we are going to get to our working directory. Our working directory is different. Okay, that should be my desktop, right? So I think where it is, I change working directory. My working directory. I have four similar proteins: 1ENY, 2B35, 2NV6, and 40RN. These are enoy reductase proteins receptors in Mycobacterium tuberculosis. So SWAN has been, I think the oldest amongst them is 1ENY, and the one most recent should be 40RN at the end here. But in between, we have a mutant protein, these two NVCs that has been changed in one uh, in one of the amino acids in the sequence. So I'm going to load all four of them, control click, all four, and then OK. Symmetry none, we leave it as it is. It's okay like this. Then we click OK. Okay, the first one is loaded, second one is loaded, third one, and then fourth one. Now we have a very big issue here because it looks like we are not seeing the full picture. So I zoom out, and this is what we have. The only few problems we are having now is I don't know which is which. Okay, I just clicked off 1ENY and I realized there is something that changed here. Let me turn it on again. You'll notice it there. So it's like there are two receptors here, but they are closely related. So turn it off again, turn it on. Okay, let me see what's in 1ENY. Just receptor, solvent, and then ligand. Really do not need this solvent. Let's see 2B35, turn it off. Oh, 2B35 is a very large protein. It's the one taking up most of the space. And this is because it contains, I think it contains, oh, there are over 6 ligands here. 1, 2, 3, 4, 5, 6, 6 ligands here. And then the receptor itself, okay? I think the receptor contains 6 chains as well. Good. Now for 2NV6, also just one ligand. 4TRN, just one ligand. But for us to see it better, we translate and move this center. Okay, see, domain. Now, now, for us to see the sequences, we can just click this SEQ up here. Have the sequences here. Really do not need solvent. I can delete them. If you want to delete them, you can just, this is it, HOH, 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 complete. You can just click them and then delete if you want to. But I will hold on for now. I really do not need, I also, okay, see for each one we have one ENY, A chain, A chain, A chain. For 2B35, we have 1, 2, 3, 4, 5, 6 chains. And then ABCD, these are also the ligands on those chains. Then 2NV6, we have A chain, A chain. This is ligand, and this is isoniazid rather than triclosan. Okay, this isoniazid, and then this solvent. There's no solvent for 2B35. And then for 40RM, it also has chain E, just one chain. Then it has NAD, mother, mother ligand. Okay, now I will enlarge this. We have this complete. If you don't want to view them this way, you can come down here to this point. If you want to see it as either number and yeah, you want it numbered like this. Some people prefer that like this. You can click like this to just have only numbers. So I prefer it like this since I can see this and it gives me more space to work with. Also, if you don't want the 3-letter arrangement, amino acid arrangement, you can click the next one, and then we have just one letter for us to work with. And then you see that this HOH here is written as www, representing water or true. But I don't like that, so I'll just use this. Now, it's time for us to align, superpose them. So we have it here. You can use here, you can come here, new one. So align, superpose, click to align, and then we want to align. Either you click align here, or superpose here, they are the same thing. So I will use superpose. They will tell me the sequences of the protein chains do not seem to be aligned. We align now. So we align first. And then, so first thing is doing you align, and then it superposes for you. So yes, I want it to do that for me. Wait for a while. And is it going okay? I think it's done. Good. Now, if we see here, scroll down, zoom into, now we see something here. See that everything has been, is like they are crammed together. See everything crammed in together, all together. So this has been superposed on each other. And here we see the RMSD here, 0.311 angstroms. And if you want to plot it, we can plot it. This makes so much sense. We can save this as an image. We can, yes, save this as an image, and even see it as a graph down here, the RMSD, and we can select the ones we want to calculate the RMSD for. So 1ENY with 2B35 is this, 1ENY with 2B35 chain B is this. So these RMSD, they are very good, and we have this as our reference. So from 0, 0.51, these are really acceptable, really good. Then from 2.53 upwards, these ones are not really good. But we see that the RMSD for even the wild types and the mutants, they are almost alike. And I think I didn't show that. This is 2NV6 chain A. I will look at line, I think 94. If you notice, most of them are having the same from 1ENY, glycine, leucine, aspartate, glycine, valine. I think there is one that will change when it comes to 2NV6. Okay, let me see where it is. I think it will be 94. Okay, yes. So for 1ENY, serine, 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 serine. But when it comes to 2NV6, this is alanine. The last one also is still serine. So this is where this is a mutation here that was done on 2NV6. On 2NV6. So even after aligning the only difference between 1ENY since it's a very old receptor that most of them start the receptor with methionine, but 2NV6 and 1ENY, as old as they have been, they don't have the first one. Even 40RN contains methionine. So this is basically how you can really check um, the RMSD for every one of them, and you can superpose as many as possible. You can select you want to calculate RMSD by residue. You want a reference and then calculate with the rest. So let me use 40RN as reference, and then it's still the same thing. Still the same thing. And then you can export this as a picture, export this as a photo. You can use any format you want to, and you can save it the way you want it to be saved. Yeah. This is how you can do that. This is how you can set up your protein and calculate, superpose several proteins on each other and it's the RMS value. So thank you for watching. Don't forget to like, subscribe, and also click the notification bell so that you can get more notifications on whenever we drop new videos. Thank you.